Welcome to This Explainer. Today, we're diving into some absolutely crucial material for Grade 7 Introduction to AI, Unit 4, Lesson 1. For the official record, our focus today is Lesson ID STEM-AI-Unit-4 Lesson Pack-01-Natural Interaction Worked Practice Video Overview, and the exact title is Natural Interaction Worked Practice Video Overview. So if you've ever talked to a voice assistant or a chatbot and wondered how it all comes together, and honestly, if you can actually trust it, you are in the exact right place. Here is our roadmap for today's worked practice. We'll be hitting 6 quick stops. 1. The fluency misconception. 2. Perceive, reason, act. 3. Checking trust with NIST. 4. A worked example. 5. Your turn. And 6. The final takeaway. Let's get right into it. Section 1. The fluency misconception. Let's start with a really big question. If an AI sounds smart, is it always right? You've probably noticed that a voice assistant or a chatbot can answer you so smoothly with perfect grammar and total confidence that you just automatically assume it's telling you the truth. It's totally human nature. When something speaks to us that naturally and instantly, our brains are literally wired to trust it. But here's the massive misconception we need to clear up right now. Fluency does not equal accuracy in natural language interfaces. Just because an AI chats with you effortlessly, it doesn't mean the information it's giving you is actually true. Fluency is just about how well it talks. Accuracy is about whether or not it's factually correct. And in the world of AI, those are two very different things. Section 2. Perceive, reason, act. To understand why this happens, we need to look at how these systems actually work under the hood. According to the OECD, AI operates in 3 main steps. First is perceive, where sensors collect raw data from the world around them, like a microphone picking up your voice. Second is reason, where the operational logic interprets that data to make a decision. And third is act, where actuators output a response, like playing a synthesized voice back to you. Now, that beautifully fluent interaction you're hearing, that is just the final act step, and it relies entirely on the unseen reasoning step. If the AI's reasoning is flawed, it will fluently and confidently give you an answer that is completely 100% wrong. Which brings us to Section 3, checking trust with NIST. So since we can't see that invisible reasoning step, we need a reliable way to check it. Enter the experts. The U.S. National Institute of Standards and Technology, or NIST, created the AI Risk Management Framework, which gives us 4 professional functions to evaluate AI trustworthiness. Govern sets the rules. Map identifies potential risks. Measure tests if the AI is accurate. And manage fixes any issues. For our worked practice today, we are zeroing in entirely on the measure function to test if an AI is actually accurate, no matter how human it sounds. Section 4, Worked Example. Let's see this in action. Imagine you're cleaning up after a science project in the kitchen, and you ask your voice assistant, "Hey, is it safe to mix this bleach with this ammonia?" The assistant replies fluently and instantly, "Yes, mixing those 2 household chemicals is perfectly safe and will make a stronger cleaner." Well, because we now know fluency doesn't equal accuracy, we don't just blindly trust it. We apply the NIST measure check. We test that output against verified safety data. The result? We instantly reveal that the fluent answer is incredibly dangerous and highly inaccurate. By measuring it, we prevented a serious hazard. Section 5. Your turn. All right, now it's your turn to put this into practice. Imagine you're writing a history report and you ask a chatbot when the Declaration of Independence was signed. It confidently replies, "The Declaration of Independence was signed on August 2nd, 1850. Now the grammar's flawless, but that date seems way off. Think about the NIST AI Risk Management Framework we just covered. Which specific NIST function would you use to evaluate this fluent but highly suspicious historical claim? If you chose the measure function, you hit the nail on the head. You'd apply the measure function by opening up a verified history textbook or a trusted historical website and testing the chatbot's date against the actual historical record. Because being trustworthy isn't about stringing together a smooth sentence. It's about testing the AI's output to make sure we're evaluating the cold, hard facts, not just the conversational tone. Finally, Section 6, final takeaway. Let's wrap things up with this crucial quote from the OECD. The key power of an AI system resides in its operational logic. This brilliant point perfectly sums up our worked practice today. True trustworthiness comes from how the AI reasons internally and measures up to actual facts. It absolutely does not come from how quickly or smoothly it can talk to you.
So I'll leave you with this thought. The next time an AI sounds completely human, brilliant, and confident, what risk management check will you use first before you believe what it says? Keep that NIST framework in your back pocket. Always remember the difference between fluency and accuracy, and make sure you look past the smooth interface to actually measure the facts. Thanks for hanging out with me for this explainer, and I will catch you in the next one.